Welcome to this fourth video in a way that we will learn how to and then we will learn to know how we can send part to different buffers or how we collect part from different buffers depending on how busy their buffers are. So just to summarize what we've done so far, we know this notation. We know that buffer 2 is too busy because M1 does not have any restriction for sending part to the buffer, so eventually buffer 2 is just enough. So eventually we could say that maybe buffer 3 or buffer 4 are not necessary in this model, but we know that in real life we have different stations to send customers requirement, part, component. So eventually we should find the balance between using all of them. So that's why we're going to use witness for realizing how to do that. So we create our first initial model, we answer a few questions, we got to realize that we need more information, so we learn how to add attributes and variables. They looked very complex, but in the end you saw in the previous videos that eventually was very simple and also a very repetitive activity, which means that if you practice more, eventually this will become very simple. And also we add variables that help us to do calculation across the whole model, which are up to date across the model. So the way in how we do it is that we create a global variable, which is called var total cost, which is up to date in M1 and also in M2. Now I want to learn the use of very well-known formulas, functions on witness, which are named most and least, plus the use of part and free. How this works? Well, basically, the most and least are requested to know if there are too many things about something in some place, or if there are just a few things in every place. So, for instance, if we use parts, which is going to be our example, free maybe is going to be used in another session, but at least we're going to use part. So most part looked for the place with more parts, and least part look for the place with less parts. So we will learn how to use that and in a very smart way. So what we do, as you can see here, is that now the action finish, right? When you're going to finalize the process, right? Now in here is just about to, instead of saying push to B2, B3 and B4, instead of doing that, we are going to do list part. That means that we are going to, M1 is going to send to B2, B3, B4, but to the place that has less part, right? So that will represent that maybe a component would like to be sent to a station in where there are less part being processed, or when you are going to a bank, you would like to queue the line that has less people. And on the other hand, M2 will collect part from B2, B3 and B4, but it will consider the buffer that has most part. You see, so because as soon as M2 will get realized that one of those three buffers are very busy, M2 will try to help them by collecting part from them, where if there is a buffer that has just a few parts, it essentially won't be considered. So let's see how this looks like. This is, in the end, is very simple. So M1, instead of now doing push to B2, B3 and B4, is going to do list part B2, B3 and B4. That's why I'm going to copy this, right? We just copy that text. This is exactly what I'm going to use. Don't forget to save our model right now because it's a new version. So in that way we can go back eventually. So this will be our model 3, which is really the fourth, but because we start from 0, is our fourth model, but in terms of notation, it's just the model 3. You see, because here we have model 0. So M1, instead of now doing push to ship, see in this section, now it's going to do list part. Is that correct? Is correct. Actually, you will see that if you come back again to this section, witness change this to capitals, so it used its own format. So what is it going to do is that M1 is going to send part to B2, B3, and B4, depending on which buffer has less part inside. On the other hand, we have that M2 is going to collect part from different buffers, but depending on how many parts are there. So M2 is going to make sure that it's collecting part from the buffer that has most part. You see, like that. So it's going to check B2, B3, and B4, and the one that has most part is the one that is going to choose. If there is any situation in where B2, B3, and B4 has the same number of parts, well, as we mentioned in the lecture, it's going to consider the list of event. So the first one that was created, all the time we had the priority when we have similar conditions. And because the time is fixed, right? Because the time is fixed, we like to see also some variation, but let's see how this works. So if we simulate this now, I need to save that first. So eventually you see parts are going to different places, see, which is very interesting. See, so the model is working. But of course that because the time is constant, so we don't really know, right? That's something that we need to realize. We don't really know how long parts are going to be there if the time will be probabilistic. So that makes things more interesting. So as here said example, the first machine has a cycle time of average 2 and standard deviation of 2. So sorry, average of 10, standard deviation of 2, distributed under a normal distribution. So if we double click here, we click here on cycle time, then we go to model assistant, and here we have the distribution. So we will right click the distribution that we want to use, which in this case is normal. We are going to right click over that, insert with the distribution wizard. So we know that the mean is, don't remember, I'm going to do it again, 2 and 10, sorry, 10 and 2. So here is 10, this is 2. So now this has been introduced here. And the other, machine 2, has another distribution, which is, let me show you a little, so wizard, there. This is 16 and 4. That means that deliberately we are doing the second process slower to create the queue. So in a way that we will check how this list and most function works. So this is 16 and 4. Okay, we save that. It's okay. Then we don't do nothing else. So we check that. 16 and 4. So our model now looks like this. So then if we run it, and also we're going to run the model based on the slide, which is saying that the model now should be run by 1000 minutes in order to see what else happens. So we're going to run it a bit longer. I'm going to run this. See? So we can see that parts are going to different buffers. The cycle time now is different, so that's why we have this variation, right? But you see, At this very moment, M2 is not collecting part from B3 and B4. They are only going there. You see? So eventually the model could be modified in a way that we should be able to collect part from different areas. See? So see this? This is fine. So just to review it to be the model. So now what we've done is that this is going to collect from the plate that has most part there. This one is going to send part, sorry, it's going to send part where there are less parts, see? So now we could have a more complete model, which is certainly more interesting. Actually, if we check the flow part of this, the event flow, exactly the rule. So we can run the model a bit longer. See, so that's what is happening. So now part arriving here, and if we run this, or let's say that we will run a fixed number of parts. For instance, let's say that we want to run, let's say 1,000 parts, right? And this time is going to be meaningless because we want to run just 1,000 parts. So let's see how this works. So 1,000 parts are here. Let's make this faster. So we can see how the model is working. So whenever one part will be processed here, you will see that this number is going to change. Wait a little. So this model is also very useful if you would like to realize, you see. So now part has arrived in here. So now the model starts to reacting. Yeah. So when the model will start finishing their part, you will get to realize that the figures. So we can see how interesting the model now is. So what the model is doing is trying to realize how will be the best way for collecting part from different buffers. And in this case, we're using the rule most and least. So now this finished, and now you see, because now we don't have more parts, so now it's M2 is just selecting from the place that has most parts. You see, so eventually, right now, so we'll reach the steady stage. So and we finish. So very interesting. Right now we will learn how to use the most and least, and we can see the impact. So now we had the first arrival, but M2 is going to wait till all there will have arrived, and when that happens, it's going to pull from the buffer that has the most. So that's why it's going to make the order between both parts. So don't forget to save your model. And now this is becoming very interesting because with all the variables that we have created, now we can know even more things. For instance, we can also display the number of elements in the queue. So also, for instance, it's very useful. So just for the next model, we could do this, and then we display the part Q. So make sure that because we know that there are many, so I'm going to make sure that the number is very big. So it's going to be around 6 more or less, I think, like that. So we will know the number in Q there, and the number in Q here. Display. I'm going to draw part Q, and six digit in case it's too big. Okay, we can do actually there to make sure that we can remember what the figure is about. And before the same thing, into display the part Q. There. You see, so when let's say that I want to simulate less part, for instance, 50, or let's say 100 parts. So we simulate 100 parts, and then we make them arrive in even more faster. Say very fast, and this process is also going to be very fast. For instance, yes, actually we can divide it by 2, for instance, in a way that will be the half. We're going to simulate this again. Oh, sorry, I have to restart the model. Sorry about this. Great, we save the model. There. You see, so then the model starts reacting to collect the part from different areas. So this is another way for simulating Q in theory, and you are very welcome to add some additional formulas that you may learn, that you may have learned in the lecture, that will be very useful. But now, in the next video, we're going to learn how to collect this data and write it into Excel. So don't forget to save your model again, and thank you.